Okay, so like we did in the last video, we look at another simultaneous inequality. So I call it simultaneous inequality. So this is constraint 1, constraint 2, like I mentioned in that first video. So constraint 2, constraint 3, constraint 4. So let's take constraint 1. So taking constraint 1, we have 4x plus y less than or equals to 15. 4x plus y less than or equals to 15. So we'll try and make y the subject. So we have y less than or equals to minus 4x plus 15. So we assume it were an equation. So if we assume it were an equation, it becomes y equals to minus 4x plus 15. Nothing has changed. It's still very similar to the one we did earlier. So we'll now find y. So find y when x is 0. So if we find y when x is 0, we have y equals to minus 4 times 0 plus 15. So we have y equals to 0 plus 15. So that means y equals to 15. So when x is 0, y is 15. Then we'll look for x. Now find x when y is 0. So find x when y is 0. So this is 0 equals to minus 4x plus 15. So if this one comes here, we have 4x is equals to 15. So if we divide both sides by 4, so that means x is equals to 15 over 4. And what will 15 over 4 give us? That's 3.75. 3.75. So that means for this constraint, okay, I didn't represent this, but we'll do it together. So when x, for this first part, when x is 0, y is 15, and when x is 3.75, y is 0. Now this is for constraint 1. That's the coordinate for constraint 1. Now for constraint 2, let's see what will happen. For constraint 2, taking constraint 2 now, taking constraint 2, so constraint 2 is 8x minus y greater than or equals to 9. So try and make y the subject. So we have minus y greater than or equals to minus 8x plus 9. So if we divide both sides by this negative number, the inequality sign will change from greater than or equals to less than or equals to. So this cancels this. Minus cancels minus. We have 8x. Plus over minus, that's minus. So you can now assume it to an equation. So assume it were an equation. So if you assume it to an equation, we have y equals to 8x minus 9. Y equals to 8x minus 9. So we now look for y. So find y when x is 0. So find y when x is 0. So you have y equals to 8 times 0 minus 9. So you have y equals to 0 minus 9. So that means y is minus 9. So now let's find x when y is now equals to 0. So it means anywhere we see y now, we put 0. So we have 0 equals to 8x minus 9. So if this 8x comes here, we have minus 8x is equals to minus 9. So we divide both sides by minus 8. So this cancels this. So what will 9 over 8 give us? 9 over 8. 9 over 8 is 1.125. So therefore, for this constraint, therefore, when x is 0, y is minus 9, and when x is 1.125, x is 0. So we are going to plot these two graphs on this other board. So but here we have a negative value of y, minus, and we have a positive value of y, plus 15 minus 9, but we have only positive value of x. So I'm just trying to see how we are going to divide this. So we'll take it halfway. Yeah. So this is y and this is x. Okay, the x does not need much value. Okay, so I'm going to improvise. Okay, it's okay like that. So we have y is up to 15. So I'll just use, a matter of scale, I'll use 3 for the y axis. So we have 1 2 3 4 5 6. 1 2 3 4. So this is 3 6 9 12 15 18. So I'm using 3 for the y axis. So this is minus 3 minus 6 minus 9 minus 12. That's for the y axis. Then for the x axis, I'll try and make it big. So 1 2 3 4. So this is 1 2 3 4 5. So that means in between we have 0.5. So now for the first constraint, the coordinate is when x is 0, y is 15. So this is y is 15. When x is 0, y is 15. And when x is 3.75, so this is 3.5. So 3.75 should be somewhere here. Y is 0. So this is 0. Y is 0. So for the first constraint, we are using a continuous line. I hope you still remember. So it's joining. So for the first constraint, it is less than or equals to. It is less than or equals to. So that means we are interested in this part below the line. So less than or equals to. So this is this line is for 4x plus y less than or equals to 15. Now for the second constraint, these are the coordinates. When x is 0, y is minus 9. So this is minus 9. And when x is 1.125, so this is 1. This is 1.5. So it's in between 1 and 2. So let's say somewhere here. So 1.125. X is 1.125 when y is 0. So if we join those 2 points together. So according to this now, it has changed. Where is it? It has changed to less than. It has changed to less than. So less than means below the line. So this is below the line. So it has changed to less than. So we are shading this part below the line for this one because it is below. Less than. Oh, okay, let me see that. So less than. Okay, it is less than. So we are interested in this part. Made a mistake. So we are interested in the part below the line. So that means we are shading this part. We are shading this part. Then we have x greater than or equals to 0. Now we have to take note of that. X greater than or equals to 0. So that means we are shading this part. For x greater than or equals to 0. I think there's a problem with the question, but what we are doing is actually correct. There's a problem with the question. So we have y greater than or equals to 0. So y greater than or equals to 0. So we are interested in this part. So y greater than or equals to 0. So the region that is not shaded, the region that is not affected by this represents the solution. So that means the region P that we are looking for is this place. Well, I didn't expect it to be like this, but this is where the solution to the inequality is. So that means the inequality that will satisfy, the solution that will satisfy this inequality will be found in this region that looks like a triangle. So that's it.